Assalamualaikum warahmatullahi wabarakatuh. This is from group Muhammad Adi Helmi bin Zainal, Muhammad Safwan bin Muhammad Saleh dan Muhammad Syarazi bin Sanusi. From the PBL question assignment from the Analogue BEKE 2333. We get the question 4 for our task. For the question, the figure 1 show the basic principle of CD player for computer application. At playback, the digital information is changed into analog by digital to analog converter. In the CD, the analog voltage is amplified by power amplifier and it will drive a speaker that produce the original analog sound. Design a class AB power amplifier for the CD player system with a 6 ohm speaker. With the output power of the power amplifier should be approximately 4 watt. For the figure 4, this one. Okay, the first question we need to do is identify the design solution based on fact, idea, learning issue, action solution, or non by Philas table. The second is to design the power amplifier circuit with a BJT as the active device. And the third one, we need to stimulate the circuit and analyze the result, determine the power dissipated, useful power being delivered to load, and the efficiency based on the calculation and simulation. From the Philas table, the first fact that we get is CD drive waveform is digital signal. And the idea from that, we got the sound wave are usually in sinusoidal wave. Learning issue, how to change the digital signal to analog signal. And our action is use the right device to change the signal. For our solution, we use the power amplifier digital to analog converter. The second fact is the input is in DC but the output is in AC. The idea from that, we need a converter to convert digital signal to analog signal. Learning issue from this second, what type of converter should we use? And our action is to identify the right converter to use. Lastly, our solution, use digital to analog converter. The three fact is the input of power supply must be sufficient with load. The idea from that, the output power must be 4 watt from the question we get. The learning issue from that is what the parameter must be varies to the achieved output power of 4 watt. Our action is set the VRMS to 5 volt, then find the VL, PO, PI, IL, IDC, and PQ. For the VRMS, we already tried for the value for 4 VRMS and 5 VRMS. And 6. The 5 is mean like the exact value because for the 4 and 6 we get the value far away from 4 watt. And the solution for our last fact is we use the formula PQ equal to PI minus PO over 2.
Adik for the introduction and explanation about Philas table. So my name is Muhammad Safwan bin Muhammad Saleh. Nombor metrik B0117101921. So I will go further about the task 2. The task 2 asks us about to design of power amplifier circuit using a BJT by use class AB. So basically, first of all, we need to know class AB. Class AB is a amplifier that combination class A and class B to achieve an amplifier with more efficiency than class A, but with lower distortion than class B. So by using the multisim software, we design class AB, which a 6 ohm speaker and power source using a 5 VRMS. Can stop. Uh, V1 we put 5 VRMS which frequency 1 kHz while DC voltage source which the label V2 and V3 are 0.7 respectively. The V2 and V3 act as a diode which the voltage drop for silicon diode is 0.7 volt. In simulation part, the multimeter is connected in series to measure the current flow of ICC. The type of transistor that being used in the simulation are bipolar junction transistor and PN2N222A and PNP which code 2N3702. The value of VCC and VEE are 12 volt and negative 12 volt respectively. Oscilloscope is connected in parallel with the load resistance to measure the output voltage and obtain the waveform, as we can make a calculation to find the power output approximate to 4 watt. We adjust the time based scale. After that, we run the circuit and click the oscillator. We adjust the time based scale to 1 millisecond per division. Based on simulation in multisim, we obtain the value of current IDC. Macam tu. Yeah. Based on the simulation in multisim, we obtain the value of current IDC is 349.48 milliampere and output voltage peak to peak and output voltage peak to peak is 9.99. I'm sorry. The voltage peak to peak is 6.659 volt. To calculate the output power, the output voltage must in Europe meter square. So after that, we use another value in VRMS which change 5 with 4 and 6 value. Next, for the task 3, I will pass the mouse to Muhammad Syarazi bin Sanusi.
Thank you for the great explanation. Okay, I am Sharazi. I'm going to explain on calculation. We used two methods for the calculation. First was theoretical and second was simulation. For theoretical, we're going to use VRMS equal to 5 VRMS, VCC equal to 12 volt, resistor equal to 6 ohm, VI equal to cert 2. So we want to find VRMS, which is cert 2 times 5. We're going to get 7.07 volt. This is going to be our VL. So we want to find the first power output, which is VL square divided by 2RL. We're going to get 4.165 watt. After that, we're going to find IL, which VL equal to RL equal to 1.178 ampere. For IDC, we're going to use 2 over lambda times IL, which we're going to get 0.75 ampere. So on power input, we use VCC times IDC, which will get 12 times 0.75 is equal to 9 watt. After that, we're going to find PQ, which P input minus by P output divided by 2,
which we can get 2.4175 watt. For the percentage, we gonna use P output divided by P input times 100%, which we get 46.28%. On simulation, we get IDC on the micro, multi-sim, multi-sim, the 349.48 milliampere. The output was 6.659 volt. For V output RMS, 6.659 divided by Z2 equal to 4.709 V RMS. Power output, we use V output square root by divided by R, which R we use 6. We get 3.695 watt. For P input, 2 times VCC times IDC, which we get 8.388 watt. The percentage we get for the simulation method was 44.05%, which slightly less than theoretical method used. A B class amplifier show that if you get percentage is near to 50%, it was an ideal. So 5V RMS was ideal, but we still use other parameter value for comparison, which is we use 4V RMS, which the percentage we get for the theoretical was 37.04%, and in simulation was 40.42%. And another one was 6V RMS, which in theoretical value percentage was 55.56%, and simulation method was 53.38%. So this it showed that 5V RMS have the nearest percentage value to 50% than other. So in conclusion, we can conclude that 5V RMS it was the ideal, because from the question, the power output that question 1 was 4 watt, with in 5V RMS we get for power output was 3.695, and in the percentage of the value was 44.05, that is nearly approximate to 50%. That's all from us. Thank you, Dr. Maas, for teaching us. We hope that you can accept our assignment. Hashtag keep smiling.